So we're going to continue our discussion in section 7.4 about how we can actually generate our confidence intervals instead of just interpret them like we looked at in the first couple of examples. In order to generate our examples, we're going to have a list of steps that we're going to go through. We are going to use some of the information from section 7.3 in our central limit theorem. But then before we can do anything, we need to find our margin of error. So our margin of error is going to be the amount that is both added to and subtracted from our sample proportion in order to give us our confidence interval. Our margin of error is going to be found by taking a product of a z value, right, which we're going to call a z star value, which we're going to see some more information about in the table below, and then our standard error. Our standard error is the same standard error formula that we used in section 7.2, in the last couple of examples in 7.2, and then we used in doing our central limit theorem problems in section 7.3. Right, so what do we need to know about our z star value? Our z star is a number that tells us how many standard errors we want to include, and it is determined by our confidence level. Right, our z star is a z-score, right? And if we're using our empirical rule, right, thinking about our empirical rule, how many standard deviations are we moving away from our mean? A z star of 1 would correspond to a confidence level of 68%. A z star of 2 would correspond to a confidence level of 95%. And a z-score of 3 would correspond to a confidence level of 99.7%. Right? Now, for our purposes, as we're going through these problems, we're not necessarily going to use our 68% or our 99.7%. Instead, we're going to use confidence levels that vary between 80% and 99%. As we are doing these, for the most part, so far we've used a z-score of 2 to correspond to 95%. Notice that in this table we actually have a more specific value mentioned here of this 1.96 for our z-score. So as we're going through all of the problems in this section, we are going to be using these z-star values. For a confidence level of 99%, we're going to use a z-star value of 2.58. For 95%, 1.96. 90%, 1.645, and 80%, 1.28. Right, as we are going through these problems, we do want to keep in mind that we're going to need a normal distribution. Right? In order to have a normal distribution, we're going to need to check our conditions of our central limit theorem. So those conditions that we checked in a bunch of problems in section 7.3, we're also going to have to check those same conditions again in these problems. Right, so to find our confidence intervals, we have a 4-step process. Our first step is going to be checking the conditions of our central limit theorem, right, that our sample is random and independent. Again, we're generally going to assume that's the case unless we're told separately. That we have a large enough sample, so we're going to have 2 inequalities to test for that one, and that we have a large enough population, so we have 1 inequality statement to test for that last one. Then we're going to find our standard error. So step 1 and step 2 are identical to what we did in section 7.3. First we check our conditions, next we find our standard error. Once we find our standard error, then we're going to find our margin of error. So we're going to go to that z-star table and take a value out of there. And then we're going to find and interpret our interval when we are done. All right, so example 3 in this section is the first example. We're going to go through this entire process of finding our confidence interval. All right, so we're going to start just like we did in section 7.3 by listing what we know and what we want to know. So the Kaiser Health Tracking Poll surveyed 1,504 American adults and asked them if they supported the requirement that private health insurance plans cover the full cost of birth control. The poll found 61% of respondents supported this requirement. Find a 95% confidence interval for the percentage of all American adults who support this requirement. So our population, again, is our capital letter N. So we're going to have all American adults for our population. And then our sample size is the 1,504 American adults surveyed. Our p-hat is 61%, which is going to be 0.61. The percentage of respondents who supported this requirement. Our confidence level we're told to use 95%. And what we want to know, what we are looking for the confidence interval, which again is p hat plus or minus m. All right, so we're going to start by checking our conditions of our central limit theorem. So the sample is random and independent. We are going to say, yes, this is true. Again, we always assume that's true unless we are told otherwise. Right? That we have at least 10 successes and 10 failures. Right? So we're going to use our sample size, 1,504, times our p hat, so our 0.61. That gives us 917, which is greater than or equal to 10. And then our number of failures, 1,504 times 1 minus our 0.61. So 1,504 times 39%, or 0.39, which gives us approximately 587, which is also greater than or equal to 10. As we're doing these, if we need to, go ahead and round to the nearest whole number. Again, we're checking that after we do this multiplication that our value is greater than or equal to 10. If you are entering problems in Statcrunch, we only are going to have a couple of different values to enter. What we're going to enter using Statcrunch, and I'm just going to make a little note next to these, so that way if you do want to try this problem again using Statcrunch, you can. We're going to use our n. So we always use our sample size when we're talking about Statcrunch, and then we use our number of successes. So in this case, our number of successes we find by multiplying that sample size times our population proportion. So we would use 917. And then as we're going through Statcrunch, basically you need these two pieces of information and then your confidence level, and then Statcrunch will automatically generate the interval for you. We'll discuss that more as we get to a couple of examples later on, but just to kind of make a note, these are the two different things that you'll see reference to in our steps for finding confidence intervals using Statcrunch. All right, our large population. Right? All Americans, right, is our population, greater than or equal to 10 times 1,504. Right? 1,504 times 10 is 15,040. Right? There are definitely more than 15,040 Americans, so that condition is satisfied as well. So all three of our conditions are satisfied. Right, now that we've checked our conditions, we're going to find our standard error estimate. Again, the only difference between this formula and one that we've seen previously is whether we have a p or a p hat. In this case, we're starting with a p hat. We're starting with our sample proportion, but we fill everything in the same way. So we're going to take 0.61 times 1 minus 0.61, divide it by our sample size, which is 1,504. Right. Again, if you're plugging this into your calculator all at once, make sure you do so carefully. You use your parentheses carefully. Otherwise, multiply, divide, then take your square root, and we get 0.013. All right, now that we have our standard error, we need to find our margin of error. And notice that our margin of error, right, has this z star value in it. So we're going to go back to this table for a minute. Right? In this particular example, we're told to use a confidence level of 95%. So we're going to use 1.96 as our z star value. So we're going to take 1.96 times our standard error, which is 0.013. And we get 0.025, or 2.5% if we're thinking in percentages. All right, so then we're asked to find and interpret our interval. All right, so we're going to take our p hat plus or minus our margin of error, which is our m. All right, so our p hat is 0.61 plus or minus our 0.025. Right, so we're going to take our 0.61 minus 0.025, 0.61 plus 0.025, and that's going to give us an interval of 0.585 to 0.635. Right? So our interpretation, again, we want to start with our confidence level. So we're going to say we are 95% confident that the proportion of American adults who believe private health insurance plans should cover the cost is between 58.5% and 63.5%. Right. So again, we start with our confidence level, right? The proportion that we're looking at. So our proportion of Americans who believe that this should be covered, right? And then we finish it off by listing the actual values for our interval. So between 58.5% and 63.5%. All right, we're going to work through a couple more examples, and then we'll go through and talk about the steps in Statcrunch and then make some comparisons based on our different confidence levels. So example 4. A Huffington Post YouGov poll of 1,000 Americans found that 38% believe that there is intelligent life on other planets. Construct a 95% confidence interval for the percentage of Americans who believe that there is intelligent life on other planets. Would it be plausible to conclude that 40% of Americans believe there is intelligent life? So notice that we are asked to construct an interval, and then after we do construct this interval, then we are going to answer an additional question. Right? So our capital N is going to be all Americans. Our lowercase n is our sample size. So the 1,000 Americans surveyed. Our p hat is our 38%, which is 0.38. Our confidence level, 95%. And what we want to know, does 40% fall within our confidence interval? Which is p hat plus or minus m. Step 1, our conditions, we're going to skip them. Next couple of examples, we're going to skip them, assume that they are met. Again, if they are not assumed to be met already, go through and do your multiplications to check those different values. Right, now we're going to find our standard error estimate. So our square root of 0.38 times 1 minus 0.38 all over 1,000. We multiply, divide, then take the square root. We get 0.015. Our margin of error, our z star, just like it was in the last problem, since we have a confidence level of 95%, our z star is going to be 1.96. So we're going to take this times our 0.015, and then generally speaking, we're going to round our margin of error to 3 decimal values, right, to get 0.029. Same thing with our standard error. Right. Then we're going to find and interpret our interval. So 0.38 plus or minus 0.029. So we're going to take our 0.38 minus 0.029, 0.38 plus 0.029, which is then going to give us our 0.351 to 0.409. Right, our interpretation. We start with our confidence level. We are 95% confident that the proportion of Americans who believe there is life on other planets is between 35.1% and 40.9%. All right, so then our conclusion. Would it be plausible to conclude that 40% of Americans believe that there is intelligent life on other planets? So what we want to do is we want to look at this and we want to decide, does that fall within our interval? And yes, it does fall within our interval. So we are going to say, since 40% falls in this interval, yes, it would be plausible to conclude that 40% of Americans believe this claim. So as we did in example 2, once we have our confidence interval based on the values that we have for our interval and the question that we're being asked, we can answer an additional question above and beyond our interpretation. Right, example 5, we're going to work through one more problem, going through our entire process from beginning to end. So a political consultant randomly surveys 300 voters in a district to see how many intend to vote for a certain candidate. Of the 300 voters surveyed, 165 indicated that they will vote for the candidate. Use a 99% confidence interval. Should the consultant predict that they will win the election? Why or why not? All right. So our population is going to be all voters in the district. Our sample size is the 300 voters that are surveyed. Right, our p-hat, in this case we're not actually given a proportion, we're given a number. So we're given 165 indicated that they will. But we can easily take this 165 out of our 300 from our sample size, divide this to get a percent, which is 55%, which we can also write as a decimal 0.55. In this case, we are told to use a 99% confidence level. So we're going to use 99% for our confidence level. And what we want to know, right, should the consultant predict that they will win the election? Right, so winning the election means that we're going to be above 40%, or excuse me, above 50%. Right, so we're going to say, does the confidence interval again, our confidence interval being p-hat plus or minus m, stay above 50%. All right, so our conditions, again, we're going to skip these, assume that they are met. Our standard error, 0.55 times 1 minus 0.55 all over 300. Multiply, divide, take the square root. We get 0.029. Now we're going to find our margin of error, our z star. So we're going to go back to our little table here. We have a confidence level of 99%, so we're going to use a corresponding z star of 2.58. So we are going to take 2.58 times 0.029, and that gives us 0.075. And then our p hat plus or minus m. So we are going to take 55%, so 0.55, plus or minus our 0.075. Alright, so after we do our subtraction and addition, we get 0.475 to 0.625. So we're going to say we are 99% confident that the proportion of voters who intend to vote for this candidate is between 47.5% and 62.5%. All right. Our conclusion then. Using this interval, should the consultant predict that they will win the election, why or why not? Okay, so again, here we're looking at a range of values. Our values go between 47.5% and 62.5%. In order to predict that they would win, it would have to stay above 50%. So in this case, we're going to say since the interval contains values that are below 50%, the candidate may not win the election. So we would not want to make this prediction because of our values that fall below 50%. All right, so the last couple of questions that we're going to go through, we're going to talk about how we can use Statcrunch. So when we're using Statcrunch, we're going to go into our stat menu. We're going to select proportion stats because we are dealing with population proportions that we are estimating. We're going to select one sample in this section, and then we're going to select with summary. Then what we're going to enter, as I mentioned in the first example that we were looking for, we are going to enter our number of successes and the number of observations. So our number of successes is going to be what we get. Again, we can always take, I guess this should technically be our p hat, not just a p, times n. Okay, then we're going to select our confidence interval. Make sure we pick the correct level. Right? And then once we do that, select compute, and it's going to give us our confidence interval based on our lower limit and our upper limit. All right, so in example 6, according to a Gallup poll taken in East Germany, when adults are asked whether they were thriving, struggling, or suffering, 60% said they were struggling. Find the 90%, 95%, and 99% confidence interval for the proportion of people in East Germany who say that they are struggling. How do these confidence intervals compare to one another? Right, so we're still going to start by making a list of what we know. So our capital N, our population, right, is the population of East Germany. Our lowercase n is our sample size. And in this sample size, I forgot to type it in there. We used a sample size of 435 people. Right. So we're going to just make a little note here that 435 was the number of adults that were surveyed. Right. Our p hat is 60%, which is going to be 0.60. Our confidence level, we're going to do 3 different problems. We're going to do 90%, 95%, and 99%. And what we're looking for is we're looking for the confidence intervals, which all of them are going to set up p hat plus or minus m. Right. So since we're working through this problem using Statcrunch, again, our first conditions just depend on whether or not we're told that they're met or that that we're asked to work them out on our own. So in this case, we're just going to assume that they are all met as we did in the last couple of problems. Again, if you're asked to go through them individually, make sure you work through them and make sure they all do work as far as the inequality statements go. If we're using Statcrunch, we can skip step 2. We do not have to find our standard error estimate. If we are using Statcrunch, we are provided with our standard error. Step 3, find our margin of error. Again, we can skip this because we are using Statcrunch. Right? So then we are asked to find the intervals. So the key thing is here as we're going through and we're entering our values into Statcrunch. Right? Our n, our sample size, right? Remember, is the 435 people that were surveyed. So that is our number of observations that we're going to put in when we're using Statcrunch. Right? And then our number of successes is our x. And in this case, we aren't given our number of successes. So we're going to take p hat times n. Right? Again, if you're testing your conditions, this is one of the multiplications that you do. So we're going to take our 0.60 times our 435, and we get 261. So those are the two values that we would be entering into Statcrunch. Right, then using Statcrunch, right, the 90% confidence interval that's generated is 0.561 to 0.639. Then we can use Statcrunch again. The 95% confidence interval is 0.554 times 0.646, and the 99% confidence interval is 0.539 to 0.661. Now if we compare these, notice that as we move down, our lower limit and our right upper limit are moving further apart from one another. Right? So here we're going from about 56% to 64%. So our confidence interval varies by about 8%. Where if we get down to here, we're going from 54% to 66%. Well, now we're looking for a confidence interval that ranges almost 12%. Right? So how do these confidence intervals compare to one another? So we're going to say the 99% confidence interval is the largest. And then we can also say as the level of confidence increases, the width of the interval also increases. So as our confidence level gets larger, our interval gets wider. Then this last little image down at the bottom just shows kind of why this happens. Right? In general, as our level of confidence increases, the width of the confidence interval also increases. And if we think about our empirical rule, if we think about shading in areas, right, the larger our percentage, the more of the normal curve we are talking about. So our interval will continue to get larger and larger for these problems.